Welcome to this course on manufacturing process and control. Modern manufacturing is not just about producing goods, it is about producing them efficiently, consistently, and to the desired level of quality. Variability is inherent in any production process, and the ability to recognize, analyze, and control this variability is central to achieving high performance in manufacturing systems. This course introduces you to the key principles of recognizing process variation, identifying sources of variation, describing variation using structured methods, and applying probability and statistics to characterize processes. We will also differentiate between design specifications and process capability, and discuss how to apply core concepts creatively in new situations. Finally, we will assess how to select the most appropriate statistical methods for solving different kinds of problems. The course is structured into 2 modules. Module 1, Fundamentals of Process Variability and Characterization. Module 2, Process Capability, Advanced Approaches, and Statistical Method Selection. Module 1, Fundamentals of Process Variability and Characterization. Lecture 1, Understanding Variability in Manufacturing. In continuous production, variability is unavoidable. Even when machines, tools, and materials are carefully controlled, no two products are exactly the same. 1. Types of variability. Natural or common cause variation, small, random fluctuations that are inherent to any process. These are predictable within a range and are usually acceptable. Special or assignable variation, unexpected changes caused by factors such as tool wear, machine misalignment, operator error, or defective raw materials. These must be identified and corrected. 2. Why variability matters. Variability affects product quality, customer satisfaction, and production cost. Reducing unnecessary variation improves reliability, lowers waste, and increases competitiveness. Lecture 2, Identifying Sources of Process Variation. To control variability, we must first understand where it comes from. 1. Common sources. Machines and equipment, vibration, temperature changes, or wear and tear. Materials, inconsistency in raw material properties. Methods, differences in how operators perform tasks. Measurement systems, errors in instruments or inspection techniques. Environment, humidity, temperature, or dust affecting performance. 2. The importance of root cause analysis. Techniques like brainstorming, cause and effect diagrams, and statistical tools help identify whether variation arises from machines, people, materials, or external conditions. Lecture 3, Describing Variation in a Structured Manner. Once sources are identified, variation must be described systematically. 1. Graphical tools. Histograms show how data is distributed. Run charts display performance over time. Control charts monitor stability of processes. 2. Numerical tools. Measures of central tendency, such as mean and median, describe the process center. Measures of spread, such as range, variance, and standard deviation, quantify variability. 3. Importance of structured description. A structured description allows for effective communication, accurate diagnosis, and consistent decision-making. Lecture 4, Applying Probability and Statistics to Process Variation. Probability and statistics form the backbone of process characterization. 1. Role of probability. Probability models help quantify uncertainty. For example, probability distributions describe the likelihood of different outcomes. 2. Key statistical concepts. Normal distribution. Many manufacturing characteristics, such as length or weight, follow this bell-shaped curve. Sampling. Inspecting a subset of products to infer about the whole population. Confidence intervals. Estimating ranges where true process parameters lie. Hypothesis testing, determining whether observed differences are due to random chance or actual changes. 3. Why statistics matter in manufacturing. They allow engineers to Distinguish between acceptable and unacceptable variation. Predict future performance. Decide when corrective actions are necessary.